Okay, so I'm going to start with Polaris, since Solomon, really quickly, since Solomon didn't have time to get through it. So I'm going at Polaris. So you log in the same way as you did for Aurora. Then you enter your password. It is the same for all of our systems. All right, so here you are. So as Yasi said, I'm going to focus on Python and AI, and on the AI side, I'm just going to be focusing on PyTorch, and you can go check the docs for if you use any other frameworks like TensorFlow or things like that. Okay, so now that we are on Polaris, you can do the same as you did before. You can clone this repo.
Mariam, can you speak closer to the microphone? Some users are asking about that.
Oh, can you hear? Oh, let me just.
I can hear you fine, but I guess some of them maybe not. So maybe like a closer to the speaker or just louder.
Okay, maybe
Yeah,
it was
that's it. Yes.
better.
Yes.
All right.
Yeah.
Okay, so git clone the repo. I'm working on my home directory, but as Solomon showed you before, because I see some people don't have access to the project yet. You should work on your project directory because it has more space and all of that, and it's better practice. So I'm gonna get in there, and then I want you to check out on my branch here. So it's Argonne getting started in July 2000. Okay, so once you are here, let's go into Polaris. And then the first part we're going to go through is going to be the Python or environments. So our goal here is to show you how to add pre-built Python environments on Polaris, how to load the Conda module, and how to install your custom Python packages or Conda modules and stuff. So first I'm gonna just go on a compute node just for good practice. For like small task, very not heavy task, you can stay on the login node, but it's usually good practice to stay on the compute node. Again, so this is the queue here, R5236822, and the project is ALCF training, and I'm requesting it for, I don't need 1 hour. I'm gonna do 30 minutes. And let's just, oh, it gives me a no pass. All right. Okay, so we are on a compute node now. So again, we have pre-built environments using Miniconda, and with this you can use this GPU-supported Python libraries like TensorFlow, Horovod for like distributed training. You have PyTorch, which is going to be the main focus here, and like support for JAX and MPI for Py. So on Polaris, to load and activate, first you need to load and activate the default environment that has Conda built in it. So you do module use soft module files. Then you load your Conda environment. And then you activate it using Conda activate base. All right. And then if you need to install additional packages, I mean, here, let me just show you what packages you have. If you do pip list, you will have a long list of available packages, and like in particular for AI, you have Torch, you have like TensorFlow, tick token for tokenizing, and all of this. So it's usually the common packages you need, the most common packages you need for training or doing inference. And then if you want to install custom packages, the easiest and most recommended method is to build a custom environment on top of the Conda we have. So you do that using Python vanv. So you do Python GRM vanv, and so you provide the path to your virtual environment. So here I'm going to put it in, I'm going to call it my van, why not? And then you add this system side package flag. So that will allow you to create an isolated environment into which you can install new packages. And while having all of these pre-built packages from Conda. So you have to add this system. Okay, and then you can activate it using source. You give the pass, and then activate. Here you go. So you can see that the new environment, or the one that you just built, is activated. And then let's say you are using a custom library or package that's not here. You can use pip. So you can do, for example, Python and pip install. Let me see what is not here. I think deep speed is in there. I think we don't have. So this is just some package that's not in there. So I'm just going to put it for learning purposes. Okay, so now you can pip list again and do grep. And you can see it's here now. It wasn't here before. And now by doing pip install the package, you can have it. Another thing you'd need sometimes is using a different version of a package. Say, for example, let me see which one. So this is a GPyTorch is a package for doing Gaussian processes, which is probabilistic machine learning. So we have it on Polaris. We have version 1.11. Let's say for whatever reason I want an earlier version or a newer version. So I'm going to do Python here I am pip install and add the ignore installed flag. And then GPyTorch equal 1.6. For whatever reason, this is what I want. Oh yeah, sorry. Of course, I have to put top it up. So it's gonna install. Yes, so now you can do pip list grep GPyTorch. And you can see here that it has this updated version that you might that you wanted. So this is the most recommended way of adding Python packages, having Python on Polaris and adding custom packages or updated existing packages on Polaris. So another way of doing it that I'm not even going to show here is by cloning the Conda environment. This is not very recommended because it's a very heavy process. It takes up a lot of this storage and takes time to complete. But it's also possible to do that, just cloning the Conda environment. So you do it by, again, doing that module load Conda and then Conda activate base, and then you use Conda create. And you add the flag clone base and then prefix to the path of your environment. And then when you want to activate it, you just do Conda activate. So before we did source activate. So here you're gonna do Conda activate. So you have much more details and resource on the ALCF docs page that's linked here. So you have it here. Let me just go back. Oops. Sorry. 1 second. I'm not sure why. I can see the going back. Okay, I'm just gonna. Sorry, I have like 10,000 bookmarks. I'm just gonna do this. Getting started. And I will from Polaris here. Okay. So again, yes, you can go to this docs page to have more details, and we maintain like a list of issues and solutions. So one common issue is that you may encounter has to do with MPI for Pi. With MPI, I mean, and then to solve it, you just do from MPI for Pi import MPI. And then if you ever see this problem, this is the solution here. So again, if you have any other issue, you can still contact our support team or refer to the docs. It's pretty detailed. All right, so now let's quickly talk on PyTorch and Polaris. So let me just deactivate. So to deactivate this, you just do deactivate, and I'm just gonna stay here. So PyTorch is a popular open source deep learning framework released by Meta. And again, the PyTorch homepage has a lot of information. And here I'm just gonna show briefly how to access PyTorch on Polaris, and just briefly like the version we have, and like some very quick good practices when like using PyTorch on Polaris. So we've already done this. We've already loaded the Conda module and activated it. So let's see what Python we have. Okay, I'm just going to do Python here. So you put the Python command, and then you can see what PyTorch version is here. Import torch. Then you do torch dot version. Sorry, this is. I'm not sure how to take. Oh, just like that. I'm gonna put it somewhere. Okay, so you can see that we have the 2.3.0 version. So this was built from source, and you can find the CUDA libraries by doing echo $CUDA home. Oh, sorry, I need to quit first. Okay, and then yes, so you can see here what CUDA libraries, where they are. So you have CUDA 12.4.1. So if you want to, we recommend using this PyTorch and this CUDA. You can always try to download or install different version and different CUDA, like different wheels and all of that. And again, if you have any issue, you can always write to our support team. So just quickly, so this is just, it was just a way of simply showing you how to have PyTorch enabled on Polaris. So these are just some best practices for PyTorch when doing PyTorch applications. Common things like using reduced precision. So Polaris has a 100 GPUs. So you can use reduced or mixed precision. PyTorch has the JIT module on it. You can do multi-GPU, you can use Horovod, you can use PyTorch native DTP packages, and we have deep speed on Polaris. For more information, you can go to the deep speeds page. We have Megatron deep speed too. And yes, very quickly, if you want to run on a multi-node or something, you use the MPI exec. I think Solomon showed some example with MPI exec. So you do put the number of GPUs, number of processor per GPU, and then CPU bind. I think all of this Solomon showed, and then Python 3, whatever script or you are running here. Okay, so this is for Polaris. I want to spend more time on Aurora, so I'm gonna move there. Let me just. So what I'm doing is I was trying to see my job ID because I didn't use. I'm done on this job now, so it's good practice to delete it. And all right, so you do QDEL your job ID and you just deleted it, and then I'm just gonna log out. I'm just gonna log out from here. All right. And now I'm gonna SSH into Aurora. This is what you did earlier with Solomon. .ancf. Need to put my password. 0565 080. All right. So we are on Aurora now. Gonna do the same. Git clone. Then cd to my and then check out to the branch. So the branch name is here, Argonne getting started, July 2025. All right. Now we are going onto the Aurora folder. And we're gonna start with Python. Again, I'm gonna show you what we just did, the equivalent of what we did on Polaris, how to do it on Aurora. So Aurora also provide a pre-built Anaconda environment that makes all of these libraries available. And Aurora is an Intel system. So this was made such that it's optimized for like Intel GPU with like tools and tricks and all of that you don't have to worry about now. So here what you do module load frameworks. I can still do it on a login node, but let's just do it on a compute node. That allows you also to just get used to. So QSub again, just the same things that change here is the file system. On Aurora, it's Flare. On Polaris, it was Eagle and Grand. And the queue is different. So here it's R5822-932. And again, I'm gonna ask for 30 minutes. this one. Let's hope it doesn't. Let's hope it's as quick as it was for Polaris. It shouldn't take too much. So here again, we're going to do this model load frameworks, and the frameworks model like automatically has a automatically activate a pre-built Conda environment. So it's pretty convenient. That's right. I don't really need to do this on a compute node. So if it takes a little bit more time, I might kill this request.
Hi, Miriam.
Yes.
What job are you running there? I'm not seeing.
Yes, I'm getting into an interactive. I'm not
Oh,
running any job. So it's like this dash I here.
okay.
Requesting an interactive node.
And the
Yeah.
reason you're entering into that interactive session?
Yes.
What is the reason?
Oh, the reason is I'm not doing any. It's just to show you. I'm not like what I'm doing. So, and it's very convenient for debugging and all of that. So I have everything here, and I can see it. And I'm just doing like one node, something very small.
Okay.
I like being on interactive nodes actually because you can just
can you check, like, open another
yeah.
terminal and then check the status? Sometimes it is reserved and then
Okay.
it may not check it.
I can do that. Oh, it's okay, good. I don't need to do that. So we have we have the node now, so I can just go to go back to the Aurora folder here and do module load frameworks. Okay, so you can see it here, it's loaded. And as before, the easiest way to build custom environments and import packages and stuff is by creating a virtual environment. So it's a very good practice. You should really get into doing that to work when you are like, when you have your project, you have your virtual environment, create a virtual environment and work on it. It's just cleaner that way. So I'm gonna do Python. I'm just gonna create it here and call it my event. And then as before, we need to add the system side packages. Okay, and then I can activate it. And then, okay, so you can see here that it was activated on top of the framework, the base environment. As before, to install a new package, you have to do pip install. Let me see if I can. Let's see. Okay, so this is what you have here. Again, I think, I'm not sure it's not here, but all of these are here. I'm just gonna try to do the one I did before, pip install. By CPU. Oh, it's already there, so that's fine. So if I wanted another version, for example, let me see. Let me do the same as I did before. Let's see what GPyTorch is here. I don't see it, so I guess there is no GPyTorch. No, there's no GPyTorch, so I can do here GPyTorch. Yeah, so it's installing it. So it is the same. So like we did before. So everything that I told you about creating environments on Aurora on Polaris using Python van is through here. So all right, so this is done. So as before, you can clone the Conda environment, but again, this takes a lot of space, and yeah, so really this is the recommended way of doing it. You have additional resources here, so I recommend you go take a look on this. That might be useful to you. Okay, so now let's move to the actual AI stack. So here the goal is to show you how to use PyTorch on Aurora GPUs, because that's Intel GPUs. Maybe you have already PyTorch code on the CPU side or on NVIDIA GPUs, so it can be useful, and it will be useful, and you need it to port it. You need to know this to port it to our systems, to our like GPUs on Aurora. Okay, so as all of the popular deep learning Python libraries are supported on Aurora, so you have PyTorch, TensorFlows. They are all included in the frameworks module. Again, we're gonna focus on PyTorch, and I'm gonna show you how to train a PyTorch model on Aurora on a single GPU, and then how to do it using DDP, which is distributed data parallel, on multiple GPUs. So the first thing you need to do is import Intel extension for PyTorch, IPEX, which extend the PyTorch library and which is optimized for Intel GPUs. Like, so what is highly recommended is after you do an import torch, you add import Intel extension for PyTorch prior to doing any other packages. So just systematically, so that it's there. I think in next releases, you won't have to do it, but I think for now you have to do it to be confirmed by my colleagues on the chat. All right, so we've already done that. We've already logged in. We've already submitted an interactive job, and we've already did module load framework. So I'm just gonna deactivate. I don't have to, but I'm just gonna deactivate the custom environment that I built here. And then you can also do the same. See what torch version do we have? And then okay, so you can see we have the 2.5 version. And again, if you need a newer one, there are some fields and some you can email support. We have, I think, maybe it's not in production yet, but we have some wheels and some built for like newer PyTorch versions. Okay, so a simple but useful check here is to use PyTorch to get device information on a compute node. So you can do this, let's say, okay, so we are still on a Python. Let me add practice that I said is very important. Okay, so now you can do print. You can put it in a script, in a file, and just compile, do Python that file, but I'm just going to do it here. So you can see I'm printing. The first print is to check if like the GPU or XPU is available, which it is. So you have 12 tiles. So as Solomon said before, each node I think has 2 GPUs, and each GPU has 6 tiles. So that is a total of 12 tiles. So the current tile we are on is 0. And then you also have like the device ID here. And you can also print out the properties like the total memory. These are like things that are good to know. So this is just what I was saying, like how each Aurora node has 6 GPUs and each GPU has 2 tiles. So they are called sub-devices. It's not to be confused by PyTorch devices. So these are just like nomenclature, if I can use that word. Okay, so now let's say that you have a PyTorch code on an NVIDIA GPU or on CPU. Now I'm going to show you how to modify it on to run it on Aurora. So this one we've already mentioned. So you have to, right after you do import torch, do import IPEX, Intel extension for PyTorch as IPEX. And then wherever you had torch.CUDA, you do torch.xpu. And then when you are moving your model to like CUDA, to the GPU, to CUDA, instead of doing model.to CUDA, you do model.to-XPU. So it's pretty easy. Whatever was CUDA is replaced by XPU, basically. So here you can see it here. So the device will be torch.device XPU. If you have a model that you are moving to that device, you do model.to-device. And then the criterion also, which is like the loss. And then when you instantiate your optimizer in your model, you do model optimizer, and then you add this ipex.optimize. So it's it's not complicated to move an existing NVIDIA GPU, PyTorch code, or CPU code to Aurora. Now let me just show an example here. So this is just some demi code that summarizes everything I've just said. And that highlights the changes between like moving from CPU to going to the XPU, or going from GPU to going to XPU. So it's good practice. For example, if you just add like to define a device, like if you could say if CUDA available device is like torch device GPU, if it's not like if XPU is available, it's like the device is XPU, and then if not, the device is just a CPU. So that's dealt with. And then yes, the other changes are the one that I just mentioned. Okay, so now let's do some practice. So you can go to the example folders. And then the example, this one, and then look at the Discord is just the one. So you can see here, this is just this code here is in this script here. So we can run it. Let me try to run it before, because just sometimes you might need to make it executable, but let me see if it's, let me just, okay, you can just, it doesn't cost to do it anything. So let's just make it executable here. Okay, and then we can run it. Python. Oh, so what we can do, actually, let me show you something just to check the GPU utilization. Oops, sorry. I'm just gonna open a new, there's a way of doing it directly from there, but In the interest of time, I can't remember it now, so I'm just gonna do it here. So I'm just gonna log into my compute node from a different window to track the GPU utilization. 74. Okay, so SSH, I can here. So this is my compute node. I'm just gonna log in. Good. Okay. Here you are. Okay, so we can do, I'm gonna do the module load. And then, so this is to watch the stats. And I'm gonna add GPU ID, and it was 0, I think. Let's just see. Okay, so you can see here, it's not running now, so everything is basically 0, like 1% here, but that's basically 0. And now I can run the actual script. Okay, so while it's running, oh, sorry. How do I get out of? Fine, I can't. Oh, you should see it. Oh, yeah, it's. Is it done? Oh, yeah, it's done. That's why. I'm sorry, I didn't show you exactly what it's doing, but you can track the GPU utilization using these two lines of code. So you load the SMI and then you do watch, and then you provide your GPU ID. Let me just change this just to show you maybe better. So let's see. See, you can see the stats. So you can check the utilization on GPU 0 on a compute node, doing it like that. Okay, let me let it run. So I just added 10 more iterations. Um, 5 more steps. Okay. Wait on that. All right. So this was on a single device, single node, so a single GPU. So now let me show you how to do it on multiple GPUs. So the key steps in performing distributed training on Aurora are to load the 1CCL library, Intel's 1CCL. So I'm not sure if you know what are collective operations and all of that, but it just has efficient implementation of all of this collective operation, like all reduce, all gather, all to all. If you don't know what it is, if you are going to add PESC, you're gonna find out at PESC, or we have like different tutorials and courses on our GitHub or on our webpage. So you can learn all about what this means. So you need to initialize PyTorch DDP. You need to use a distributed sampler to partition the training data among the ranks. And you need to pin each rank to a GPU. You also need to wrap the model in DDP, rescale the learning rate, because let's say your learning rate on one, you had a learning rate on one GPU. If you have 2 GPUs now, meaning that your batch size, you have doubled it. You have also to scale that learning rate. Usually you just do linear scaling, but you can also do square root scaling or other custom scaling. And then you use set epoch for shuffling the data across epochs. So this is the dummy code for doing that. So is the change. So here we're going to use MPI. So you have to add from MPI for pi import MPI. And you have to add all of these things, these environment variables that are needed for distributed data parallelisms. Again, we have dedicated tutorials for this. This is just to show you how to run things and get you started on Aurora. So, okay, this is how you initialize distributed communication with the NCCL, the nickel backend. And then you, as I said before, you need to pin GPUs to local ranks. And all of the things I've just mentioned before that you need to add to your code. This is more involved than running on a single GPU, but you just need to do it once or twice and you'll be pretty familiar with it. Okay, so now we need, let me try to get two nodes. Let me kill this.